is example 4 from lesson 4.3, functions of the unit circle. Example 4. We began talking about reference angles, and I just want to go over those again real quick before we look at these examples. So our reference angle, when we're in quadrant 1, when we're in quadrant 1, our angle has an initial ray on the x-axis, and then the terminal ray in quadrant 1. So theta and theta prime are equivalent because when I drop down to make a right triangle, the angle I need is right there at the vertex, already inside the right triangle. So in quadrant 1, theta prime is equal to theta. So the theta prime, the reference angle, is equal to theta. In quadrant 2, now we're not in, here's the initial ray, here's the terminal ray, and I'm going to drop a line down. To solve a right triangle, I don't want that, go away. Here's theta, and that's the angle we would use inside. Well, the two of them add to 180. So theta prime would be 180 minus theta. Or, if we're talking in terms of radians, pi minus theta. For quadrant 3, our initial ray again on the x-axis, our terminal ray over here. This time we drop a line up to make our right triangle. Well, theta goes all the way to here. But I don't want that. I want this little reference angle, theta prime. And so if you look at it, I don't want all of that angle. I only want this little piece right here. So I want to ditch half of the circle, or pi radians, 180 degrees. So theta prime, our reference angle, is 180 degrees minus theta, or pi minus theta. And lastly, in quadrant 4, we have our initial ray on the x-axis, our terminal ray in quadrant 4, and we drop a line up. So here is theta prime, but the angle goes all the way around. Theta itself goes all the way around. Well, together they would go full circle, 360 degrees, or 2 pi radians. So theta prime is equivalent to 360 degrees minus theta, or 2 pi minus theta. Now it's important when we go to find our reference angle that we start with an actual angle between 0 and 360 degrees. If you look at example B, which we're going to look at in just a second, that is not between 0 and 360 degrees. So we will use, we will try to get it to a coterminal angle that does fall between that. So step 1 is going to be to make sure that you have a positive coterminal angle between 0 degrees and 360 degrees, or between 0 radians and 2 pi radians. Because if you don't have that, then it makes it tougher. So we need to do that first, and then we can find our reference angle. Now, once we have done our unit circle, you'll be much more familiar with where 5 pi over 4 is on the unit circle. And the same thing with 23 pi over 6, because you'll know your unit circle in terms of fourths and in terms of sixths. So here's what we're going to do right now. We're just going to take a quick look at the unit circle. I'm going to slide down the page and just review with you. We already know that, whoa, that's not working too well. We already have this as pi over 2 and pi 3 pi over 2. Okay, so this would be pi over 4 to cut it in half. 2 pi over 4, 3 pi over 4, because it's split it into fourths here. 4 pi over 4, 5 pi over 4. So here's where 5 pi over 4 fits. For now, on day 1's homework assignment, if you're struggling with that, that's okay. By the end of day 2, you'll know your unit circle, and you'll be able to figure out which quadrant it's in. But for day one, if you need to convert this to degrees, you can do that. Okay, it's going to be the same as 180 plus 45 degrees. So 125 degrees is its equivalent. That helps you, or sorry, 225 degrees is its equivalent. That kind of helps you know which quadrant it's in. Just want the pen. There we go. So since I know that this is in quadrant 3, that's going to be helpful. So I'm going to sketch the angle. So here it is. Here's that angle right there. There it is. So I'm going to find its reference angle. And since it's in quadrant 3, I know that in quadrant 3 I need to do theta minus pi to get theta prime, or theta minus 180. So I'm going to do 5 pi over 4 minus pi, which in terms of fourths is 4 pi over 4, because that's 1 pi. So it's just going to be pi over 4. And then so that's its reference angle. This right here is equivalent to pi over 4, what we would see here. You can see the vertical angles, at least between quadrant 3 and quadrant 1. For letter B, negative 240. Well, I know that that's, first off, that's not between 0 and 360 degrees, so I need to find a coterminal angle. I'm going to do that by adding 360 degrees. So that's going to be 120 degrees would be its coterminal angle. So 120 degrees is going to sit right in here. Okay, so it's in quadrant 2. It's important to know which quadrant it is, or you can't figure out its reference angle. Well, I know that in quadrant 2, theta prime, the reference angle, is 180 degrees minus theta. Because I'm going to drop this down, and there's theta prime right there. That's the reference angle I want. So 180 minus 120 is 60 degrees. So theta prime, our reference angle, is 60 degrees. Next, we're going to take a look at letters C and D. Take a minute to pause the video and see if you can do those ones on your own. We'll go over those in just a second. All right, letter C, 390 degrees, is more than 360. Again, we want a positive angle between 0 and 360 degrees, or between 0 and 2 pi. So when I subtract 360 to get a coterminal angle, I get that it's 30 degrees, which I know is in quadrant 1. So there's theta. And in quadrant 1, theta prime is theta. They're the same angle. I don't need to add or subtract anything to get it. Lastly, for letter D, 23 pi over 6. All right, well, I need something that's less than 2 pi. And in terms of 6, that's 12 pi. So I need to subtract 12 pi over 6. I'm subtracting 2 pi to get it, again, between 0 and 2 pi radians, which in terms of 6 is 12 pi over 6 radians. So when I subtract that, I get 11 pi over 6. Well, that's almost 12 pi over 6. So I know without even converting to degrees that that is going to be in quadrant 4. You can convert to degrees if you want to know a little bit more. So there's theta, but the angle we want is right here, theta prime. Remembering that together they add to 360 degrees, or 2 pi. What I need to do is 2 pi minus theta, and that will give me theta prime. So to do that, in terms of sixth, 2 pi is 12 pi. So this is 12 pi over 6 minus 11 pi. Parker's not working too well here, sorry. Oh, both are over 6. So that's just going to be 1 pi, or pi over 6, which is the equivalent of 30 degrees. But again, you'll get to that when we get to our unit circle. This should help you be able to find reference angles for problems that are like example 4 in day 1 of your homework. Have a great day.